Okay, the purpose of this lesson is to slow down this whole y equals mx plus b thing and make sure it's very clear what we're talking about when we say y equals mx plus b. So we're really going to take it a little piece at a time. So, once upon a line. What I mean by that is it's a stupid joke. You know, it's like once upon a time. Those stories you heard when you were a kid. This is once upon a line. Yeah, thank you. Thank you. Consider the following scenario. Jason has a job assembling bicycles. Each day he is paid $40 plus an additional $5 for each bicycle he assembles. Actually, many people in this world are paid like this. It's called piecework. You get paid to be there, but you also get paid on how much you get done. Why would you want to pay somebody like this for how much they get done? Like if you were the owner, why would you pay someone like this? When? They work harder. Yeah. But lots of people who work this way are happy to get paid this way too, because they know if they work harder, they get more money. I don't know if you ever worked a job before where you're working somewhere and somebody's getting paid the same amount as you, but you're doing more work. At least this way, if you're doing more work, you get paid more. Now, a lot of people ask about the $40. Why do they get $40 a day? Well, maybe there's other responsibilities there. They got to sweep up. They got to open up in the morning. They got to close at the end of the night. You know, there might be other things they got to do. So they're saying, okay, well, you can have $40 a day, but then $5 for each bicycle. Are these reasonable numbers to build bicycles? I don't think so. I don't think many people would take a job like this that was $40 a day and $5 for a bicycle. So I chose some nice numbers just for my example today. You know, that's all. I'm not trying to act like these numbers are legitimate. If we drew a graph to show Jason's daily earnings based on the number of bicycles he assembled, what would the graph look like? And what they mean by the question is, would this go up in a curve? Would it be changing all the time? Or would it go up in like a straight line? Would it be going up the same amount every time? That's the question. So what would happen? If you added $5 on every time, what kind of shape would you see on the graph? I really want to get the answer to that question. This is what I mean by slowing it down. I'm going to leave that program and go to a different program and really talk about that. Because that's the most important part of this lesson. Let's talk about his earnings. And I'm going to do number of bicycles and then his pay, how much he's going to get. Well, let's say he goes in one day and he just sleeps through the whole day and builds no bicycles. Or maybe he's got other responsibilities that day. How much does he get paid even if he makes 0 bicycles? He gets his $40. Anyways, let's say he goes in, he doesn't work very hard, he's talking to his friends the whole time, and he only gets 1 bicycle built. What's the total amount of money that he'll make then for the end of the day? $45 now. He gets an extra $5 for making 1 bicycle. Again, I see a couple people nodding at me with sort of a bored look in their eyes. Good. That's what we're trying to accomplish today, is make this boring and obvious. What if he makes 2 bicycles? $50. Have we got the pattern going here? We know what's happening? 3, 55, 4, 60. It's going up by the same amount every time. So if we built a graph of it, it would be going up by the same amount every time, and we'd get what we got yesterday, a straight line. So yesterday, we did lines to get ready for today, so we see what's coming. And so the answer to the question, did I go back to the beginning by accident? Yeah. No, I didn't. I'm on the right slide. Is a line. We would get a straight line if we graph this thing. So this scenario exactly fits on what we've been doing. Question for discussion. How do we know the graph will be linear? Because it goes up by the same amount every time. If it's going up by the same amount every time, we'll get a straight line. Okay. I just retyped the scenario up there so we can talk about it. Jason has a job assembling bicycles. Each day he is paid $40 plus an additional $5 for bicycle he assembles. Choose an appropriate variable. Okay, when I built the tables, I wrote number of bicycles. In math, we're not going to have to write that out like that every time. We want a variable, one letter, to represent number. Does anyone know a variable that a good letter to represent number? N. You can use whatever you want, and other times you might have seen X used, but to me it makes a lot of sense to make N for number. The other one that I was supposed to do first was, how about earnings? Well, you could use lots of things. You could use P for pay. You could use M for money. I chose E for earnings, but you'll have openings there. You'll have some choices there. Now, what is the start value? What's the initial amount? What does he get automatically? $40. What is the rate? How much is it going up by? 5. And to be honest, if this was a truly great school, I would stop right there and go, that's it. That's the big ideas we need for today. To draw a line, we need a start value. Yesterday, we just had a point and a slope, which is the rate. Slope and rate are the same thing. That is so important. I'm going to take a break. You got a poster back there that says slope on it, right? Slope is easy and fun. Just remember, rise over run. I'm going to add something to my poster because I think it's so important, and it's going to stay up there. That poster is going to stay up. You can look any time at that poster. When we're graphing, we call it slope. When it's in a word problem, it'll be usually called the rate. Yeah. And I think when I initially talked about slope, and I did my opening example about babysitting, we were talking about the rate. That's how we came up with slope. So this rate here is going to be the slope in a second. Create an equation that modeled Jason's daily earnings. Oh, that's not easy. Oh, that is not easy. This PowerPoint acts like, oh, so you got the equation? No, 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 no. No, 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 no. You can see it on the screen there. I'm going to build it. I'm going to take this exact scenario. I'm going to start talking about how we could do it without the table of values. You might think the table of values is good. It is good. But if he says, I built 20 bicycles, you're not going to want to build a table of values to do it. So here we go. Some examples. Let's say his number of bicycles is 10. Yes, I could build the table all the way down, but boy, oh boy, that's getting big. How would we come up with how much money he would make? Well, how much does he start with? 40. Plus he gets more. 5 times 10. And we could work that in our calculator. I hope we're good enough at BEDMAS that we can do that. I'm not going to do that here. What I'm going to jump ahead and say, hey, now that I know this, I could do 33 bicycles. What would he get paid, or how would I figure out what he gets paid for 33 bicycles? What's his start value? 40. And then instead we multiply 5 times 33 this time. And we'd use BEDMAS to figure it out. I'll jump right ahead. I love doing 99. Once I do 99, most people are like, I'm with you. I know what you're up to here. If he sold 99 bicycles, what would he start with? 40. Then he gets $5 times how many bicycles? 99. And that's where the equation comes from. The equation is not trying to be complicated. The equation is trying to say, if you're doing this yourself, and you want to find your earnings, all you do is go E equals 40 plus 5 times N, where you put, oh, PowerPoint doesn't love me writing on it, but I'm going to force it to. Let's see if I can get this to work here. pointer options, pen. I want you to write this on yours. Pointer options, pen, ink color, green. Let's see if green works good. Sub in number of bicycles. So all the equation is saying is, if you want to know earnings, just put the number of bicycles right in there and you'll get earnings. The equation's like, how do I do this without a table of values? I don't want to have to go plus 5, plus 5, plus 5, plus 5, plus 5, 99 times. I can just do that right there, and with a little BEDMAS, get the answer. Oh, you got any questions? Do you have the questions? All right. All right. So, what we're going to do is, once we're given a situation like this, we can make the equation just by knowing the start value and the rate. We're going to then make a graph. So on the next page, we look at this and go, okay, that's the start value, that's the rate. And if we want to graph it, we'll find it just as easy as yesterday. Okay, you got your graph there? Ready? If he sells 0 bicycles, how much money does he get? 40. So right at 0, you put a 40. Dot right there. Incidentally, some of you, your brain might be coming online going, oh, this is what he was doing the last couple of days. Pencil? Ruler. Oh, he says, he knows what's coming. He knows he needs ruler. Here, I'll come. I'll hand them out. I'll deliver. Who else needs a ruler and is not going to misuse the ruler?
Why you look
by hit?
me?
I'm looking at everybody.
Because you would misuse it. What?
Right under the bus. He threw you right under the bus. Did you see that? He didn't even hesitate.
Bro.
Oh, that's 2 bro. No, use 1. 1 bro per sentence, then wait 5 minutes and use another bro. Yeah, come on. Let's not overuse. It's funny if you use it once in a while. Bro, it's funny. 7 times in 3 sentences. I don't know. Is that supposed to be funny?
It's just a word.
Okay. Now I have the 40 there. If he sells 1 bicycle, now how much does he make? 45. So you just go up by 5. But notice, it's the same as we were doing yesterday. Rise 5, run 1. Well, it's 5 because the scale's in 5s. Yeah, 1 box, but each box worth 5 today, right? So, okay, how about if you sell? I have to keep reminding myself, my job is to bore you today. My job is to make you go, I think I really get that. Because with what we're going to do next, things might get a little difficult. We got to get this perfectly. So what if he makes 2 by? Just like I predicted. Do you see? Abusing his ruler. What if he makes 2 bicycles? Up to 50. And maybe you don't need to keep thinking like that. Once you know the rate, maybe you're not thinking like that. You're just going, oh, up by 5, 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 all the way along. Do you have a question about that?
This doesn't make sense.
Which part? Which word you want to talk about?
I'm joking. No.
Oh, you're happy?
Yeah.
You're happy, okay. I took you at face value there. I took it that you meant it. Now I drew a line through it because we drew a line through it yesterday. This particular situation, I probably shouldn't draw a line. We will. We won't care. Do you know why? He can't build 3.5 bicycles or 4.1 bicycles. He really shouldn't have a line. But we're not going to worry about that too much. But I just mentioned it. I know I shouldn't really draw a line. It just should be a bunch of dots. But we'll draw the line. We don't care. Questions for discussion? Is it really appropriate to draw a line? No, I already said that. You probably shouldn't draw a line, but we're going to go ahead and do it because it shouldn't include all the points. Yes? Do we really need to draw all the points? No, we talked about that yesterday. Once you got 3 or 4 and you got a ruler, you got the pattern, you can just go. I like drawing a lot of them just to make sure I get it just right, but you don't have to. Any questions there, friends? Do you need more time? Okay. Here's where this gets difficult. If you thought all that was easy, here's where it gets difficult. For reasons that aren't clear right now, let me jump ahead to later in the semester and into next year's math. We prefer to write the variable first. What do you mean by write the variable first? I wrote this equation like this, with the number first and then the variable term second. There is many good reasons to write it the other way, so we start switching this over, and that can mess you up a little bit. From here on in, I don't want to write it as 40 plus 5n. I'm going to write it the other way around. I'm going to write it as 5n plus 40. That's all I'm going to do on this page. Yes? 40 plus 5n really looks like it makes the most sense, but we'll start writing it as the other way around. We'll write the term with the rate first, and then we'll write the, quote, start value second. The way I've explained it, that may seem like a bad move. It may seem not too bright to do that. But I know some things you don't know. I know what's coming later in grade 10 and into grade 11, and this will be a better way when we're doing those things, okay? That's the most important page you've got going. Yes? So please copy down exactly what's there and all the arrows very carefully, because that's the most important page, especially if you've been bored in this lesson all the way up. If you're like, I totally get all this. Then this is the only part you really got to worry about, is that we'll usually see it the other way around. The rate with the variable first and the start value second. If we got that, the rest we're sailing. We're going to be sailing the rest of the way. It's going to be good. Yeah. And I know some of you on your sheet said you don't really like when the teacher talks the whole time. I get that. I'm going to do now 5 examples of that, and then I'm done. That may seem like a lot, but they will go fairly quick. Do you need more time there?
Yeah.
We often refer this to, we often call this y equals mx plus b form. You're like, why? There's no y's and x's. I know, we're going to start using y's and x's. Instead of e, we'll use y. And instead of n, we'll use x, but really the same stuff. And the m is the slope, which is the rate. Yes? M slope, m rate.
I forget what B is.
B. I'm going to talk about that in the middle of this. I'm going to give it another word. Right now, it's the start value. That's what we've been calling it, the start value. Okay? And I'll give it a new name in the middle of this. Maybe in about the 3rd example, I'll just throw the new name in there for you. Okay? Anyways, here it is, y equals mx plus b. In a big box. Why isn't it? Why did it stop? There we go. Yeah. Whoa. Stop. This box here, this bottom line on your sheet, that's the line that you'll refer to a lot. Do you remember seeing y equals mx plus b last year?
Yeah.
Yeah, so hopefully it rings a bell, but hopefully I've slowed it down and gone, wait a minute, let's just talk about this again so we're clear what's going on with all these things. Over the next couple of minutes, I'll just keep saying, what's the number with the x? And you'll say, rate. I'll say, what's the number by itself? You'll say, start value. And we'll just keep saying that over and over again, trying to make it so you'll remember it come quiz or test time. Okay? Do you need more time?
Yeah.
No? Yes?
Yes.
Did you copy it down?
No.
Oh, copy it down.
Yeah.
It's not on there for me. It's on there for you. I'll find my water. Okay. On we go. Now we just practice it. Question.
Exactly. In a
That sentence needs some more words. Huh?
Can I go to the bathroom?
Yeah. Draw a graph for each of the following equations. Okay, here we go. Here's what I want you to do on each of these. If you follow my procedure, life should be easy. The number with the x. What is that in the context of this question? Oh, I'm not in green anymore. I don't like that. I'm switching to green. You got time to think about it while I get this.
I think the red dot on the
Do 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 booty do woo. It's okay. I got it. I'll go over here and do it. Did the green work pretty good? I think it did work pretty good. I'll turn off touch screen. Here we go. There we go. Arrow right at that 3. What does the 3 represent in the middle of all this? I don't know. I'm not worried about it. That's the rate. And what's the other word for rate? Slope. So if that's the rate, what's the 2? Start value. Get ready in case you remember the other word for that in a minute, because I'll be looking for that. If that's true, then all I need is to do what I did yesterday, which is put on the start value 2. Yes? And then use the slope. Okay, it's not a fraction. So what did we do with 3 when we wished it was a fraction for rise and run?
You put 1 under it?
Yeah, just put 1 under it. So from there, I rise 3, run 1. Same as yesterday. Rise 3, run 1. From that point, rise 3, run 1. How many do I do? Well, I like to go right to the edge of the page. That way I know exactly where to put my ruler, but you don't have to go right to the edge of the page. You just need a few so that you can then draw your line. Now, so if you did yesterday's, you're like, okay, it's a lot the same. Point, rise and run. So true. But do you have any questions? Okay, here's another one. We'll do all the same thing again. What's this number? That's the rate or the slope. What's this one? What? The y. She's almost got the word. She almost remembers the word. Y-intercept it's called. Of course it's called the y-intercept. Yes, it's where we meet the y-axis. So we might start using just slope and y-intercept. You might just start using those words. I'm not trying to push that. I'm just trying to say those are where those words come from.
I only remembered it when I noticed the 2 and on the y-axis.
So where does this start? 60 on the y-axis. Now the slope's negative 10, so that's the rise, but what's the run? Put it over 1. So negative 10 rise. Negative 10 rise. What does that mean? Am I going up or going down? Down. So down 10 over 1. Down 10 over 1. Down 10 over 1. Down 10 over 1. All the way down till you get to 0. Can we go past 0? Yes, we'll talk about that in just a second. But in this example, you just go down to 0. And then you draw the line with your ruler. Who's got questions? Notice you got to look at the scale, though. When I went down 10, I had to look at the scale and go 5, 10. It really depends on the scale of the question. Okay? So you got to look carefully at the scale. There's one in the homework where you're going to have to play out the scale and make your own decision. What questions do you have? Do you need more time? Okay, now's the part of the lesson to give away what math lessons are usually like. Now I do ones that might mess you up a little bit. Just things that, even if you really get that, might cause you a little bit of trouble. So I'll do 3 examples to try to help you avoid trouble. Can we also use negative numbers? Yes. 4x plus 1. What's the slope? What's the y-intercept? And I did that one with the other words. I almost said new words. I don't know if they are new. They're just different words, slope and y-intercept. Does the same thing as rate and start value. But the only difference here is going to be start value 1, slope rise 4, run 1, rise 4, run 1, but we keep going backwards into the negatives. That's what I meant by doing negatives, is we make the line go all the way through. And actually, we were sort of doing that yesterday, so maybe that's not as big a deal as I'm making it out to be. Get out your ruler and draw the line. The next one's complicated. Yeah, we're going to have to talk a little bit about decimals for the next one. And then we have one final example. Last one. No, last one graphing, last graphing one. Okay. Slope 2.5. Start value -3. So where am I starting on the y-axis then if it's -3? Down at -3. But then I got to go up 2.5. That's weird, but it's not that bad. Up 2.5. Halfway between -1 and 0. The nice thing is about halves is the next one will be right on a point again. If you go up 2.5 again, it's right there. Go up 2.5 again, it's halfway between. 2.5 again, it's right there. So that's not, I mean, we don't want any crazy decimals, but some reasonable decimals aren't going to cause us too much of a problem. Good time for that one. And then the tough question of the day. We are going to need somebody clever to help us with this one. Because that's the last of the ones I do. Then you've got homework 1, 2, 3, 4. That's all. 1, 2, 3, 4. That's all you got. Mr. Todd, why is there so little homework in this class? We're trying to help you learn to do homework by making it achievable. And then, yes, I will slowly start adding more and more. It won't get out of hand. It never gets out of hand in this class. But there'll be a little more to do on any particular day. Do you have questions on either of those? Do you need more time? Yeah, you need more time. Okay. More time still? Yes, more time? Okay. Xavier. Sure. Okay, the tough one. Brain ready. Here we go. Things get crazy here. One more example. Determine the equation of the line. This time they give me the line. I've got to make the equation. That's different than all the other ones. The other ones, they gave me the equation. I had to make the line. I'm going to have to think backwards here. What were the two important words today, though, that I'm looking for to build the equation? There's two things I got to know about the line before I can build the equation. What do you like? Start value and rate. That's my game. Find the start value, find the rate. Now, I gave the start value another name. I gave it the name y-intercept as well. Yeah. Oh, yeah. No, the rate was slope. Yeah, that's right. So where does this one start on the y-axis? What's its start value? -2. So I got that already. That wasn't so bad. Now I've got to find the rate or the slope. And I have, oh, I still got my pen. That's good. I'll let you look at it for just a second. I'm going to ask him. But I want you to think about it for a second. How could I get the slope? It's not as bad as you think to get slope. Yes? How am I getting slope here?
3.
Oh, you already know. He's like, I don't know how to get it. I just know what it is. He just looks at it and knows what it is. What are you using to do that?
Look at all like points or that weird square thing, triangle.
Yeah, he says draw the triangle. That's exactly what we were doing the last couple of days. Yeah, you're all caught up. We just said, okay, there's a little, it's actually called a rate triangle. You'll use it in science. They'll call it a rate triangle. And he looks and goes, okay, run one, rise 3. He's mostly right. What kind of 3? -3, because this is going downwards. So then, I can get the start value. -2 was the start value. I can get the rate. -3/1. And then there's pressures on to actually write the equation now that you've got the rate or the slope and the start value or the y-intercept.
Isn't that y equals -3x plus -2?
I like -3x plus -2. I would never mark that wrong. I'd be so happy to see it. But you could also write it as -2. She says, couldn't you also write this like this? And I totally agree. Some people will like this better, and so do I. Totally good to write it that way. Or because adding a negative is the same as subtracting, you could just write it as subtract. That's fine too. All they did was take those numbers and fill them into the equation that we already knew. Do you have any questions? Okay, that homework might go pretty quick. However, I will warn you, there is 2 difficult questions that you're really going to have to look at if you want to get them right. Number 2D, you better look closely at that. It's got a problem on it. Number 4B, it's got a problem on it. So pay attention, closely attention to those. The other ones, life should be pretty straightforward, so you should be okay. Your time is your own. Use it wisely. I'm going to come around and check yesterday's homework in just a minute.